Now, let's look at another very important source of error in our pipelined ADCs, capacitor mismatch. In an ideal world, all the capacitors we use in our MDAC circuit would have the exact values we designed them for. For example, all the unit capacitors, labeled C_1 through C_2M, would be perfectly identical. However, in the real world of chip manufacturing, there are always tiny, unavoidable variations. This means C_1 might be slightly different from C_2, and the feedback capacitor C_F might not have the precise intended value. This is what we call capacitor mismatch. So why is this such a big deal? Remember, the operation of our MDC is based on charge conservation, and its accuracy depends critically on the ratios between these capacitors. The equation for the residue voltage, V_, shows this clearly. The gain of the stage, which multiplies V_in, and the voltage that gets subtracted, which involves V_, are both determined by these capacitor ratios. If the ratios are wrong because of mismatch, then both the amplification and the subtraction will be inaccurate. The graph on the right gives us a clear picture of the consequences. It shows the residue voltage V_s versus the input voltage V_in for a 2-bit stage. Ideally, this sawtooth pattern should fit perfectly within the range from plus V_ to V_, which is the input range for the next stage. But with capacitor mismatch, two major problems can occur. First, look at the areas marked with red circles. Here, the residue voltage is overshooting the allowed range. The peaks are going above plus V_ and the troughs are dipping below V_. This typically happens if the mismatch causes the stage's gain to be too high. When this residue voltage is passed to the next stage, it's out of range, causing that stage to saturate. This saturation introduces a large error, and it can cause the final ADC to completely skip certain output values. We call this phenomenon missing levels. The second problem is illustrated by the purple circles. In this case, there are gaps in the residue voltage. You can see that the end of one sawtooth segment and the beginning of the next one don't line up. This means there are certain V_s values that are never generated by this stage. Since the job of the following stages is to digitize this residue voltage, if a certain range of residue values is never produced, the corresponding final digital output codes will never appear. This is what we call missing codes. So, capacitor mismatch is a fundamental limitation that directly attacks the linearity of our ADC. It can cause both missing levels and missing codes, both of which degrade the performance and reduce the effective number of bits of the converter.